Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, how are you today? Today we will learn about our hospital rules by Ms.Rara. But before that, if you like my video sharing about knowledge, please like, share, subscribe my video channel, and then give me energy to upload maybe every week. Okay, so let's talk about what is our hospital rules. Our hospital rules provides a technique to evaluate limits of indeterminate form, so an expression that can be easily evaluated by substitution. Okay, so that's the meaning. This method help us evaluate limits of indeterminate form. Okay, so the hospital rules talk about the two. The first is indeterminate form 0 over 0, and the second one indeterminate form infinite over infinite. So the first we talk about indeterminate form 0 over 0. Let us consider the following limit where both fx and gx approaching to 0. So that's the meaning limit x approaching a fx over gx. When we substitute x equal a in this limit, we obtain a fraction of the form 0 over 0. So maybe you think, what's the connection between this method and this indeterminate? So that's why today we want to know what's the connection about our hospital rule and then limit indeterminate form. So please stay tuned and enjoy my video. Let the function f and g be differentiable on an open interval that contains the points a. Suppose that limit x approaching a f x equal limit x approaching gx equal 0 and limit x approaching a derivative of x and derivative of gx exist. Then this limit function of a function equal limit prime over function over g function is equal L hospital rules. So you need to remember there is three notes about this indeterminate form. The first, before using this method, you need to verify that we have the indeterminate form 0 over 0. What should I do, miss, with the verify? You should substitute this x approaching something to the function. If the function showing that form is 0 over 0, so you can continue to using this method. Using this method, differentiate both the numerator and denominator separately. Remember, separately. So, you cannot using this one to be the equation rule. No, it's not allowed. So, you need the derivative numerator first and denominator first. Okay, the third, in fact, about this method, when we using this method, still gives 0 over 0, we can apply it again until we get different result. Maybe you will using our hospital rules like 4 or 3 times until you get different result, guys. Don't worry, because that the step we will because that the step when we until we get the result. Okay, let's talk about example. Find limit x approaching 0 sinus x over x. So you need to verify that this formula is indeterminate form. So sinus 0 over 0 is 0 over 0. So this one is true. So we can continue to using this method, our hospital rule. Derivative of sinus x is cos x. Derivative of x is 1. So you just need to substitute x approaching 0 to this function is cos 0 equal 1. Okay, everyone? I think you understand. Another example. Limit x approaching 4, x minus 4 over x squared minus 4. When you want to, like, okay, let's say you forgot to using that verify, so you just need to continue to using this method. You will get the result 1 over x. Oh, maybe you think this one, oh, maybe this one is correct, miss. No, guys, this is wrong. Why wrong? Because you need to verify this one. Because this one, it doesn't give indeterminate form 0 over 0, because the result is 0 over 12 equals 0. So you cannot using this method. Remember, you need to verify don't forget to verify this function, this limit of function. Okay. Another example. Limit x approaching minus 1, x power cube plus x plus 2 over x plus 1. You need to verify this one, guys. Verify because we need to know what is the indeterminate form. Ah, thanks God, this one is 0 over 0. So you need to continue to derivative both sides separately. Derivative of the numerator is 3x squared plus 1. Derivative of denominator is 1. So when you get until like this, when you substitute is not 0 over 0. So this one is correct. So the result is 44. Okay, everyone. Another example. Limit x approaching minus 1, square root of 2x plus 3 minus 1 over square root of x plus 5 minus 2. You need to verify this one. The first thing you need to verify what this form. So when the form is 0 over 0, so you can continue to derivative both sides separately. Derivative of this one is this one when we simplify. And then when we get like this, you just need to substitute the x approaching minus 1 to this function. And then you will get 2 times square root of 4 over square root of 1 is the result is 4. So this one is correct. Okay. Another example, find limit x approaching 0, x minus sinus x over x squared. So we need to verify that, first if this one indeterminate form. So we already know in here when we substitute 0 is 0 over 0, so that's the meaning is indeterminate form. So we can continue to using the L'Hospital rules. So you need to derivative each other. Derivative of x is 1. Derivative of sinus is cos x. Derivative of x squared is 2x. Okay. So once we substitute this one is 0 over 0. So that's the meaning we should do L'Hospital again. L'Hospital again, when you what the function of you will need to use is when you after you derivative from the first, and then this one is the result, you can using this function and make it to derivative again. Okay, derivative of 1 is 0. Derivative of minus cos x is sinus x over derivative of 2x is 2. When you substitute x over approach 0, sinus 0 over 2, sinus 0 is 0. 0 over 2 is 0. So this function have limit 0. Another example, find limit x approaching 1 exponent power x minus ex over x minus 1 square. When we want to verify this one, you need to substitute the x approaching 1 to this function. So the result will be 0 over 0. So that's meaning that this one is indeterminate form. So you can continue to the L'Hospital rule. So limit x approaching 1, we need to derivative each other, the both side. So derivative is exponent x is exponent power x. So derivative of ex is still exponent. So this one is the how to get this numerator, and derivative of here is 2x minus 1. Okay, when we derivative, when we substitute this x approaching 1 to this function, is still a 0 over 0. So you need to make it L'Hospital again from this function. Derivative of this one is exponent power x. Derivative of this one is 2. So when we substitute 1 to this function, exponent power 1 is exponent over 2. So the result is exponent over 2. So everyone, so now we will talk about the indeterminate form in infinite over infinite. So let's talk. In indeterminate, the infinite over infinite, L'Hospital rule is also valid for this. It is expressed as follows: limit x approaching a f x equal plus minus infinite, and limit x approaching a gx plus minus infinite, and limit x approaching a f prime x over g prime x exists, then limit before the limit function equal limit prime. So this one is equal with the hospital rule. This method, remember, this method cannot be applied directly to the indeterminate form, infinite times 0 and infinite minus infinite, but it may be possible to convert them into 0 over 0 or infinite over infinite. So you need to remember when you substitute this approaching to the function, and then the result have the result like this one or like this one, so you need to convert this one to be the 0 over 0 or infinite or infinite. Okay, friend, that's the difference between 0 over 0 and infinite over infinite. So we will talk another example. Example for limit x approaching infinite, x squared minus 3x plus 5 over 7 plus 2x minus 3x squared. When you substitute this function, the result will be infinite over infinite. So you can continue to do a hospital rule, everyone. So you need to derivative the both sides. So derivative of this one is 2x minus 3, and derivative in the denominator is 2 minus 6x. So when you substitute the x approaching infinite, the result still infinite over infinite. So you need to do another hospital rule. The derivative of this one is 2 minus over minus 6. So the result is minus 1 over 3. Okay, let's take another example. So limit x approaching infinite exponent x plus 2x over exponent 2x minus 3. When we substitute this one, the result will be infinite over infinite. So you need to derivative the both side. You can derivative the both side, what I mean. So derivative is exponent power x plus 2x is exponent power x plus 2, and derivative of exponent power 2x is that the function itself times the prime of this power. So 2 times exponent power 2x. When we still substitute about this one, the result still infinite over infinite. So you can using the not rule L hospital rule again, everyone. So when we derivative about this one, derivative of exponent power x itself, and then derivative of this one is exponent 2x is 2 times exponent power 2x. So this one is get 4 times exponent power 2x. So it's equal 1 over infinite. 1 over infinite is equal 0. So this one is the result. Okay. Another example. Find limit x approaching 0 plus 1 over x over ln x. The solution, when we can have derivative, it's the both side, we can make it derivative. So derivative of 1 over x is minus 1 power x squared, and derivative of ln x is 1 over x. So the result is minus 1 over x. When we substitute 1 over 0 is correct, infinite, because this one have minus. So the result minus infinite. Another example. Limit x approaching infinite, x times minus 1 over x. When we substitute this one to be this one, is the indeterminate form is infinite times 0. You should change this form to be 0 over 0. Let x times sinus 1 over x is equal limit x approaching infinite sinus 1 over x over 1 over x. So when we substitute x approaching infinite, the result is still infinite. So we can continue this one to be L hospital rule. Derivative of sinus 1 over x. Derivative of sinus is cos 1 over x. But they have the function. Derivative of this function is 1 over minus x power 2 over derivative 1 over x prime is minus 1 over x squared. So we can cancel each other about this one. And then we can substitute x approaching infinite to be this formula, 1 over infinite is cos null equal 1. Okay, it's easy, right? Another example, limit x approaching 0. When you substitute this approach to this function, the result is infinite minus infinite. But we can rewrite this one to be 0 over 0. You can make this one to be have the same denominator, and then you can face this one. So the result 0 over 0. And then you can continue this function to be using this method is a hospital rule. So you need to derivative each other. Derivative is exponent x is their self. Derivative of x is minus 1. Derivative, you get, because in here they are using the product rule. So let x to be u, let this function to be phi. X is 1 and this function exponent power x minus 1 plus u times p prime is exponent x, and then when we substitute this one, the result still 0 over 0. So we can using another hospital rule. So derivative of this one is exponent power x, and then derivative of this one exponent power x, yes, exponent power x minus 1 derivative is null, so we don't need to put this one, and x time exponent power x, this one is product rule. So let x to be u, let phi to be ex. So derivative is x is 1 times exponent power x plus x time derivative of exponent power x is their self. And then when we substitute x approach 0 to this function is 1 over 1 plus 1 equal 1 over 2. So that's it, everyone, about a hospital rule. So this one, the exercise. Please do exercise. Just check yourself 1 and 2 on page 84 and 86. Thank you for today. I hope you learn more about our hospital rules, because this our hospital rules is make us easier to solve the problem about the limit indeterminate form. If you like my video, please like, subscribe, and share, and comment. If you have a suggestion for me to make it better about my channel. Thank you for today. Assalamualaikum warahmatullahi wabarakatuh.